Welcome. This question says an electric field of 7 newtons per coulomb points in the positive x direction. What is the electric flux through a surface that is 2 square meters if the normal to the surface is inclined at 70 degrees elevation above the positive x-axis while being in the xy plane? So a lot of words. Let's visualize. So here's our xyz. Here's our x, here's our y, and here's our z, three-dimensional space. And then I have my electric field. Let's draw our electric field like that. It's 7 newtons per coulomb in a positive x direction. And then we have our surface, and our surface has a normal, and that is 70 degrees elevation. So here's our A, and it's 70 degrees elevation above the positive x-axis while being in the xy plane. So that's a good representation of it. I'm imagining a kind of surface like that, and we have the surface normal. This is a really beautiful thing. What they did was to simplify the visualization of electric field and Gaussian surfaces in order to work out flux. They invented a vector which is perpendicular to the surface of interest, and this enables us to characterize a surface and its inclination in space by a simple area vector. And then we have all the advantages of working with vectors, so we can see that we're finding a relationship between an electric field vector and an area vector and flux, and the relationship is the so-called dot or scalar product. So what we say is, oh, well, in that case then, we say flux is equal to E dot A. That's a vector, that's a vector, and we can write this out in the longer form. It's the magnitude of E times the magnitude of the area times the cosine of the angle between. And so in this case we can see that flux is equal to, my value for E is 7 newtons per coulomb. So there's my value for E, and my value for A is 2 square meters. And the angle between them, if I look at my diagram, it's 70 degrees. Now, it's very nice because I gave you the right angle to be working with. There's lots of angles I could have given you, which would be the same diagram, but I could have given you the angle to the vertical axis. So don't just say, oh, I take whatever angle's there and shove it into my equation. You've always got to visualize. And if we go along and look at numbers, we can say our flux is equal to 7 times 2 times the cosine of 70, and that is going to equal, and it's going to be 4.788, which is 4.8, and it's going to be, well, it's still going to be electric field multiplied by area, so it's going to be Newton meter squared per coulomb, and there's my answer. So this idea of, rather than trying to characterize the surface, the area by the angle between the plane of the area and some axis, is possible, but more often than not we characterize the area by its surface normal, its area vector, which is completely invented, and it enables us to make use of the dot product, which makes life much easier. So it's a really beautiful thing. So there we have it.